Hello again, my name is Marcelo, and today I'm going to be doing Project Euler problem number 4. The problem number 4 is about finding the largest palindrome product. A palindromic number is a number that reads the same both ways. Largest palindrome made from two-digit number is 9009, so you can see that 9009, if you reverse it, is 91 times 99, it's still 9009. We need to find the largest palindrome made from the product of two three-digit numbers. So let's start a little bit with the theory. I'm using Python, but again, you can use whatever programming language you want. We have two numbers which are between 100 and 999, A and B, and they produce a number which is the same, reading from both ways, between 10,000 and 999, 999. So it's either 5 or 6 digit long. There are two ways we can go about this. We can do the brute force way. The brute force way would just be make number and check if it's a palindrome, check if it has two digits multiplier. This is very inefficient because finding the factors would be very costly. We can of course do just two fours here, so you just do something like 4 from range 100 to 999, and then kind of the same for B, for 4 from 100 to 99 again, and then you just get a palindromic here, and then you check if it's a palindrome, and then get the largest one. We can optimize this a little bit by just starting from 999 all the way to 100 and just going the opposite way instead. This would make it a little bit more optimal because it would probably find a large palindrome first since you want the largest one. But we can do better. An interesting thing to note here is that it's either 5 or 6 digits long, so between 10,000 and 999999 we have 990,000 numbers, with 90,000 of which are 5-digit numbers, and the remainder 900,000 are 6-digit numbers. So it would have at most three different digits, x, y, and z, and it would be written either as x, y, z, yx if it's 5 digits, or x, y, z, z, yx if it's 6 digits. I'm just going to assume that it's 6 digits out of probability, and if it is not, then you can fail back and try and find it for 6 digits. So we can kind of make some assumptions here. So we know that each of these is a different digit between 0 and 9. And we can kind of separate this into its own numbers. So if we consider that this equals pretty much 100,000 x plus x to 10,000 y plus y, then y plus 1,000 z plus 100 z. Now we can kind of join these terms together. So 1001 plus 100,001x plus 10,010y plus 1100z. So you can kind of represent this number like this, knowing that each of these are different digits, and then this would produce a palindromic number that is 6-digit long. We can, and of course this has to be the product of A and B. We can go a little bit further here, is that we can factor out. So if you check out that 11, all of these are actually factors multiplyable by 11. This would be 9001x by 910y and 100z. And since 11 is a prime, we can be sure that either A or B have to be a multiplyable by 11 as well, so you can actually just change A to be 11A1. So by this logic here, we have two numbers that multiplied themselves, multiplied by 11, would equal a palindromic number. And from this on, we can actually just make a few more conclusions. So we know that 11 times A1 has to be between 100 and 999, which is useful for us because so 11 To generate a 3-digit number has to be at least 10, because this would mean that it equals 110, and if it's 9, this means that it would equal 99, which is not 100, or if it's 90, then it would equal 90, but if it's 91, it would equal 1001. So we actually know that A1 is from this is between 10 and 90. And we can go a little bit further than this, because we know it's not 10, because we cannot have this number multiplied by 10, because otherwise it would have a leading 0, and we cannot have that. And we know it's not 1190 for the same purpose, so we know that it's at most 89. So this reduces already our range by a lot, so we can start from 89 and go all the way down to 10, non-inclusive. But for B we kind of maintain the same range, but the thing is now that it actually reduces a lot. So now we have around 80 numbers times 900 numbers, which is about 72,000 from 990 that were here before. So we have 72,000 possible candidates, and we can do a little optimization here. Is that we know that neither of these numbers can be divisible by 10, so we can add another condition here that just checks if A is divisible by 10, we just continue on the loop, and if B is divisible by 10, we just continue on the loop as well. And we can go a little bit further in this. So because we are always reducing, in this case by 11, and in this case by 1, we know that we start with a very low large number, very low large palindrome, and if our current number, which is, so we start with a p here, which equals 11 times a times b. Once again, have to put this 11 back here, because a is only counting from 999 from 89 to 10, and we have to multiply it by 11 based on the formula. We know that if p is smaller than the largest, then we can break out of the inner loop. Otherwise, we have to check if p is a palindrome. So we can probably write this function later. P is a palindrome. Then we already know that it's bigger than the largest one, so we can equate it to the largest one. And then in the end, we just print the largest one. Let's just delete all of these proof of concept code here. And now we just need to write the palindrome. So there are lots of ways of doing this. Since we know that it's always going to be 6 digits. We could just compare each digit, but there is a quicker way, which is not the most performant way. Is that we just get the number here, and then check if it's equal to its reverse. So I think this should work. Once again, here, just gonna loop decrements from another loop of 2 digits, and then one of 3 digits, and then get the multiplied of that by 11. Check if it's smaller than the current largest one, because then it doesn't matter. And then if it is larger than the current one, if it's a palindrome, then we reduce it. So if you try this, we get a good response. And then again, this is quite fast. It has very few comparisons. It finds the number pretty much instantly. If you like this video, let me know. Subscribe, follow, like on the video, comment if you want to see any other problems that you might want to be watching. Once again, thanks for watching. See you in the next one.